The search for life on alien planets has been one of the most exciting frontiers of science, and the James Webb Space Telescope has brought us closer to answering this question than we've ever been before. Just imagine for a moment the vastness of the universe. Billions of galaxies, each teeming with billions of stars, many orbited by their own families of planets. Could we be alone in this cosmic ocean, or are there other worlds out there teeming with life, perhaps even looking up at their own night sky, wondering the same thing? Here's an exploration of the possibilities and what the James Webb Space Telescope has uncovered so far in our search for life beyond Earth. So how do we begin to search for life on planets we can barely even see? Well, it starts with deduction. We know that life, as we know it, needs certain basic ingredients to exist. Water, for example, is crucial for life as we know it, acting as a solvent for biochemical reactions. Then there's the need for a source of energy, like sunlight, and a stable environment that isn't too hot or too cold. These are just a few of the conditions that make a planet potentially habitable. But how do we detect these conditions from trillions of miles away? The answer lies in the light that planets reflect from their host stars. By carefully analyzing this light, we can identify the chemical fingerprints of different molecules in a planet's atmosphere. These are what we call biosignatures. Think of them as clues, whispers from distant worlds that might just betray the presence of life. One such biosignature is the presence of oxygen. Here on Earth, our atmosphere is rich in oxygen thanks to billions of years of photosynthesis by plants and algae. If we were to detect significant amounts of oxygen in an exoplanet's atmosphere, it would be a very strong indication that something is producing it and that something could be life. Methane is another intriguing biosignature. While it can be produced by geological processes, it's also generated in abundance by living organisms, including those right here on Earth. Finding both methane and oxygen together in specific ratios would be even more compelling, as these gases would normally react with each other and disappear unless something was constantly replenishing them. Beyond the atmosphere, we also look for signs of habitability on a planet's surface. The presence of liquid water oceans, continents, and cloud systems similar to Earth would all be promising signs. While the James Webb Space Telescope can't directly observe these features, it can detect variations in light that suggest their presence. For example, a planet with oceans might reflect light differently than a planet covered in deserts. Similarly, the presence of clouds could be inferred from the way they scatter light. It's like putting together a puzzle piece by piece until a clearer picture of a distant world starts to emerge. When we imagine alien life, it's easy to conjure up images from science fiction, intelligent beings, perhaps more advanced than ourselves, with whom we might one day communicate. While the possibility of intelligent life is certainly tantalizing, it's important to remember that life in the universe could take many forms. In fact, the most likely type of extraterrestrial life we might encounter is microbial. Single-celled organisms similar to bacteria or archaea here on Earth represent a simpler form of life that can thrive in a wider range of environments, even those that might seem extreme to us. Think of the extremophiles found in volcanic vents on the ocean floor or in the dry, frigid deserts of Antarctica. These hardy microbes demonstrate that life can flourish in conditions we once thought impossible. Detecting microbial life, however, presents its own set of challenges. Unlike intelligent life, microbes don't build radio telescopes or launch spacecraft. Their presence would be revealed only through subtle changes in a planet's atmosphere or the chemical composition of its surface. Intelligent life, while statistically less likely to be common, is far more captivating to our human curiosity. We've long been fascinated by the idea of other intelligent beings in the universe, civilizations that might have developed advanced technologies or even solved some of the mysteries that continue to elude us. The search for extraterrestrial intelligence, or SETI, focuses on finding evidence of such civilizations. This might include detecting artificial radio signals, laser pulses, or other techno-signatures that would indicate a technological civilization. While we haven't picked up any alien broadcasts just yet, the search continues, fueled by the profound implications such a discovery would have. It's important to remember that our current understanding of life is based on the single example we know, life on Earth. It's entirely possible that life elsewhere could be based on completely different chemistries, utilizing elements and processes we haven't even considered. the universe is full of surprises, and the search for life beyond Earth is a testament to our boundless curiosity and our desire to understand our place in the cosmos. Searching for life among the stars is a bit like trying to hear a whisper in the middle of a hurricane. The universe is filled with noise, radiation from stars, the faint afterglow of the Big Bang, even interference from our own technology, and picking out the subtle signals of life against this backdrop is an immense technological challenge. Detecting biosignatures in the atmospheres of exoplanets requires incredibly sensitive instruments. Telescopes like the James Webb Space Telescope are marvels of engineering capable of collecting and analyzing the faintest glimmers of light from distant worlds. But even with these advanced tools, distinguishing between the chemical fingerprints of life and those produced by non-biological processes can be tricky. For example, volcanic eruptions can release methane into the atmosphere, mimicking a potential biosignature. Similarly, certain geological processes can produce oxygen even without the presence of life. That's why scientists are developing sophisticated models to help them interpret the data and rule out false positives. Distance also poses a significant hurdle. The farther away a planet is, the fainter its light, making it even harder to analyze its atmosphere. Even with the James Webb Space Telescope's incredible reach, we're currently limited to studying relatively nearby stars and their planetary systems. Another challenge is the sheer diversity of exoplanets. We've discovered thousands of exoplanets so far, and they come in a staggering variety of sizes, compositions, and orbital configurations. This diversity makes it difficult to predict where life might be most likely to arise and what forms it might take. Despite these challenges, scientists are optimistic. The rapid pace of technological advancement in astronomy, coupled with our growing understanding of exoplanets, gives us hope that we're on the right track. Each new telescope, each new observation, brings us closer to answering the fundamental question: are we alone? Chapter 4. Peering into the Cosmic Cradle. While we haven't found definitive proof of extraterrestrial life just yet, the James Webb Space Telescope has already made some incredible discoveries that are fueling our search. One of JWST's primary missions is to study the atmospheres of exoplanets, and it's already provided us with unprecedented insights into the chemical makeup of these distant worlds. One of JWST's early triumphs was the detection of water vapor in the atmosphere of WASP 96b, a giant gas planet located nearly 1,150 light-years from Earth. While this planet is far too hot to support life as we know it, the discovery showcased JWST's remarkable sensitivity and its ability to detect even trace amounts of molecules in exoplanetary atmospheres. Perhaps even more exciting are JWST's observations of planets in their habitable zones, the regions around stars where conditions are just right for liquid water to exist on a planet's surface. One such system that's captivated astronomers is TRAPPIST-1, a red dwarf star located about 40 light-years away. This system is home to 7 Earth-sized planets, 3 of which orbit within the habitable zone. JWST has already begun studying the TRAPPIST-1 planets, and while it's too early to say for sure whether any of them harbor life, the telescope's observations will help us determine whether these planets have atmospheres, and if so, what they're made of. Beyond studying individual exoplanets, JWST is also giving us a glimpse into the very birthplaces of planets, protoplanetary disks. These swirling clouds of gas and dust left over from the formation of stars are where planets form. JWST has detected complex organic molecules, the building blocks of life as we know it, within these protoplanetary disks. This discovery suggests that the ingredients for life are being incorporated into planets from the very beginning. It also hints at the possibility that life may be common throughout the universe, arising wherever conditions are favorable. JWST's exploration isn't limited to planets like our own. It's also providing us with valuable insights into gas giants, icy moons, and other celestial bodies that were once considered unlikely places to look for life. For example, JWST has been observing Jupiter's moon Europa, which is thought to harbor a vast subsurface ocean of liquid water. The telescope's observations are helping scientists to better understand the composition of Europa's surface ice and search for potential plumes of water vapor that might be erupting from its ocean. Chapter 5. A universe of possibilities. Imagine, for a moment, the societal and scientific earthquake that would follow the announcement, "We are not alone." The confirmation of life beyond Earth, even microbial life, would be one of the most profound discoveries in human history, forever changing our understanding of our place in the cosmos. From a scientific perspective, such a discovery would open up entirely new fields of study. Biologists would be eager to understand how alien life forms compare to those on Earth, whether they share a common ancestor, and what unique adaptations they might have evolved. Chemists would delve into the biochemistry of alien life, exploring whether it relies on DNA and proteins like life on Earth, or if it utilizes entirely different molecules and processes. The discovery of extraterrestrial life would also have profound philosophical and societal implications. It would challenge our anthropocentric view of the universe, forcing us to acknowledge that we are not the center of creation and that life may be far more common and diverse than we ever imagined. Such a discovery could also spark a new era of international collaboration. The search for life beyond Earth is a global endeavor, and the discovery of alien life would likely unite humanity in a shared sense of wonder and curiosity. Imagine nations coming together to share knowledge, resources, and technology in a collective effort to learn more about our cosmic neighbors. Of course, the discovery of intelligent life would raise even more profound questions. How would we communicate with them? What could we learn from each other? And what would it mean for the future of humanity? These are questions that science fiction writers have been grappling with for decades. And while we don't have any concrete answers yet, the possibility of one day encountering an alien civilization is both exhilarating and a bit daunting. The search for life beyond Earth is ultimately a search for ourselves. Chapter 6. The future of the search. The James Webb Space Telescope is just the beginning of our search for life beyond Earth. Its groundbreaking observations are laying the groundwork for future missions and discoveries that will continue to push the boundaries of our understanding. One of JWST's most exciting prospects is its potential to detect even more subtle biosignatures in exoplanetary atmospheres. As scientists develop more sophisticated models and techniques for analyzing JWST's data, we can expect to uncover even fainter traces of molecules that might betray the presence of life. For example, JWST could potentially detect imbalances in the ratios of methane and oxygen in an exoplanet's atmosphere, a telltale sign of biological activity, or it might identify other more complex organic molecules that are indicative of life. Beyond biosignatures, JWST will continue to deepen our understanding of exoplanet atmospheres as a whole. By studying the composition, temperature, and dynamics of these atmospheres, scientists can build more accurate models of exoplanets and better assess their potential for habitability. The data collected by JWST will also be invaluable for guiding future missions. The telescope's discoveries will help astronomers to prioritize targets for future telescopes, such as the Nancy Grace Roman Space Telescope, set to launch in the mid-20s. The Roman Space Telescope will be able to observe even fainter objects than JWST, and will be particularly adept at discovering rogue planets, planets that wander through space without orbiting a star. These rogue planets, though seemingly adrift in the darkness, could still potentially harbor life beneath their surfaces. Another exciting prospect is the development of even larger and more powerful ground-based telescopes, such as the European Extremely Large Telescope, currently under construction in Chile. These telescopes will have unprecedented light-gathering power, allowing them to study the atmospheres of exoplanets in even greater detail. The search for life beyond Earth is a journey that will likely continue for generations to come. But with each new discovery, each new technological leap, we move closer to answering one of humanity's most profound questions. Are we alone? Chapter 7. Are we alone? Finding life on alien planets is not just science fiction anymore. With the James Webb Space Telescope leading the charge, we are making unprecedented strides in understanding the universe and the potential for life beyond Earth. While we haven't found definitive evidence yet, each discovery brings us closer to answering the ultimate question: are we alone? The quest to find life beyond Earth is a testament to our insatiable curiosity, our scientific ingenuity, and our deep-seated desire to understand our place in the cosmos. As we continue to explore the universe, we must remember that the discovery of extraterrestrial life, should it occur, would have profound implications for humanity. It would challenge our assumptions, broaden our perspectives, and perhaps even redefine what it means to be human. But for now, the search continues, fueled by the same sense of wonder and exploration that has driven us since we first looked up at the stars and wondered what might be out there.